All right, I just wanted to go through the putting it all together Nearpod activity for today, in case you had any questions about how to fill it out. Again, we were talking about mixtures, so the point of today was basically putting it all together just to make a mixture. Key vocabulary, we talked about matter. Remember, matter is anything that has mass and takes up space. Talked about pure substances, which are your elements and your compounds. They are the same throughout. They include your elements like iron and gold and copper. Anything on the periodic table, it's just one type of atom, which is an element. And they include your compounds, which are your two or more elements chemically combined, things like water and salt. On the other side of this table, we have mixtures, which are two or more substances that are physically connected. We can separate them through physical means, and those include those that are homogeneous or look the same throughout or look uniform throughout, like apple juice, or heterogeneous, where they look might differ in composition based on, like salad dressing, where they have different amounts of materials in them. Today, we're going to be working on reviewing the substances and mixtures and identifying various characteristics of the material to help in the identification. Need a lot of equipment. We started off with our first ingredient, which was water. So let's go ahead and start talking about water. Come on.
Chemistry of water. Water is an inorganic molecule that is the most important compound in the body. In fact, a normal adult's body weight is made up of 50% or more of water. A molecule of water has one oxygen atom covalently bonded to two hydrogen atoms. Covalent bonds being
So H2 water is H2O, 2 hydrogen, 1 oxygen. That is the formula for water.
Covalent bonds being the chemical bonds that are formed by the sharing of one or more pairs of electrons by the outer energy levels or shells of two atoms. Water molecules are also polar molecules.
So what do you think? Why do you think that water is called a polar molecule? Is it because it's shaped like a pole? Is it because they're only found at the North and South Pole? Is it because the molecule has poles or positive and negative charges like a magnet's poles? And it is in fact that it is like a magnet. A water molecule has a positive side and a negative side, kind of like a magnet, which causes water to do some interesting things that we'll talk about later in the year.
Even though the oxygen atom shares electrons with the hydrogen atoms, the electrons are not shared equally within the molecule. This gives the oxygen side of the molecule two partial negative charges, and each of the hydrogens a slightly positive charge. This means that each water molecule can form up to 4 hydrogen bonds with adjacent water molecules. Hydrogen bonds are the result of an unequal charge distribution on a molecule. These molecules are said to be polar. This property allows water to act as a very effective solvent, which means it is able to dissolve or break apart many other substances.
So if I'm breaking apart salt water or Kool-Aid, the water is dissolving the material. The material being dissolved or broken apart is the powder or the salt, and that is always called the solute. So that is the solute.
Substances that do dissolve or break apart in water are called hydrophilic, which means water-loving. Nonpolar substances that do not dissolve in water are called hydrophobic, or water-fearing. Some substances, such as glucose molecules, dissolve and remain intact in water, as water molecules surround the substance, forming a hydration shell around the molecule. Some substances dissolve and dissociate or break apart in water. Table salt, or NaCl, when added to water, will dissociate to form positive sodium Na ions and negative chlorine Cl ions.
This is more information than you
with hydration shells
need.
forming around each ion. This property of water allows it to function as a transporter, as water-based fluids, such as blood, transport substances dissolved in water throughout the body. Nonpolar hydrophobic substances, such as fats and cholesterol, that do not bond with water, must be enclosed within a transport protein molecule to be transported within blood. And that be the basics of the chemistry of water.
So the last question, what elements make up water? Since it's H2O, we're talking about 2 atoms of hydrogen, 1 of oxygen. All right. From there, we went on to a quiz talking about water, which is our first substance. Because H2O is a molecule made up of 2 or more elements that are chemically combined, they are a compound. I always connect chemical and compound. They both start with C. If it's chemically connected, that is a compound. There are 2 atoms of hydrogen in every water molecule. Water is H2O. That subscript 2 represents that every molecule of water has 2 hydrogen. There are 1 oxygen atoms in every water molecule. Because water, the O has no subscript. If an element is in a formula, that means it's there. If it has no subscript, that means every molecule only has 1 of them there. And because water is a compound and is the same throughout, it is considered a substance, mostly because it's the same throughout. Elements and compounds are substances. Undaba. Okay, next thing we did, we added the salt to the mixture. Remember that the chemical formula for salt was NaCl. It is a combination of sodium, which is with the symbol of Na, used to be called natrium, and chlorine, which is the symbol of Cl. If there are no subscripts or none of those numbers in a chemical formula for salt, that means there's only 1 of those atoms in each pair of salt molecules. Because it's 2 or more elements chemically bonded and has a chemical formula, which in this case is NaCl, it is a compound. Remember, if it has a formula, it is a compound because it's 2 or more atoms combined chemically, and they have to be different kinds of atoms. Okay? If you were to look through the microscope, you would see salt. Salt looks like this through a microscope. It has a cubic shape to it because of the way it's structured. I added the salt to the water and I stirred it so you can no longer see it. That's the process of dissolving. And the combination of water and salt when stirred was a homogeneous mixture. Another word for homogeneous mixture is a solution. In this solution, the solute, or what was being dissolved, is the salt. That's what's being broken apart. And the solvent is the water. That's what's doing the dissolving. Water is a really good solvent. It's often called the universal solvent because of its polarity. It tends to break down everything over time. Okay, so now I had a solution of water and salt. Why is that? Is that a formula for that? Yes or no? Why or why not? And I recorded there is no formula because it is a mixture, and the mixtures are combined physically. The answer I said for my recording. There is no formula for the salt and water solution because it is a mixture. The materials are not chemically combined. Okay. And then we added the aquarium gravel. I stirred it for 30 seconds. What happened was, after I stirred it to 30 seconds, those large gravel rocks sank to the bottom. The gravel and the water are not the same throughout the cup. They all sat at the bottom, which makes it, based on this marking, that makes it different throughout, which makes it heterogeneous. And finally, because the salt, water, gravel are a mixture, they are bonded physically. Remember, a mixture is a physical bonding. I could pull them apart easily. If it's a chemical bond, it is not so easy to separate. Okay. Last step we did, we added some iron to the mixture, stirred it up. When I was done stirring it, what we noticed was that the iron sank down to the bottom because it is more dense. Are the amounts of iron, gravel, and salt and water the same throughout the mixture? No, they are not. The gravel was on the bottom. Some of the iron was on the bottom. Some of the iron was on the top. Because it's not evenly distributed, that is a heterogeneous mixture. So no, so what kind of mixture is that? If it's not the same throughout, it is a heterogeneous mixture. Make sure you submit. I didn't submit right there, but make sure you do. So we had our mixture of water, salt, sugar, gravel and iron filings. I wanted you to include one way we could separate things out. So people have magnets, some people have filters. So I could say you could evaporate the water to leave the salt behind. It's called separation by evaporation. And I could post that, and it would add it to my posts. When you get to that, you are done. And that is the first part of our lab. We will do the second part of the lab tomorrow. I hope that was helpful. Otherwise, have a great day.